and good day, Algebra. We are going over PO22, which is converting from one form of a linear equation to another. We talked yesterday about slope-intercept form, and let's write it down again up here. Not the definition of it, but what it looks like, the form, y equals mx plus b. And there's another form of a linear function that gives us different information. We like slope-intercept form. We're going to like it very much in PO23 because I believe that's when we start graphing. But what slope-intercept form tells us is it gives us the slope, that's that m, right? And it gives us the y-intercept of the line as well, that's the b. Okay, so we like slope-intercept form for that reason. It gives us two pieces of information about the line. Another form of a linear function is called standard form, and it looks like this. ax plus by equals c. And this is a good form to use if you're looking for the x or y intercept of the equation, and we'll talk more about that later on. Also, when we start solving systems of the equations, we like our equations in this form as well. It just gives us different information and has other uses. Okay, it's not better or worse than slope-intercept form. It's just what you're doing with it. Okay, kind of like decimals versus a fraction, right? Decimals, fractions, 0.75 and 3/4. You know, you got the fraction form and then 0.75. They both have their place. If you're baking, you want 3/4 of a cup. It's usually given to you in fraction form. If you're dealing with money, it's 75 cents, not 3/4 of a dollar. Same thing, right? But it kind of depends on what you're using it for, okay? So it's important to know, though, how to convert from one form to the other, right? Because if you're given the equation in standard form and you want to know the slope, standard form doesn't really tell you that, okay? Or if you're given the equation in slope-intercept form and you want to know the x-intercept, slope-intercept form doesn't really tell you that. So today's purpose is going to be converting from one form of the equation to the other, similar to the value of converting between decimals and fractions, but just with a whole more complicated stuff, okay? So steps to convert from slope-intercept form to standard form. Tell me what the difference is, before we do this here, what is the difference between slope-intercept and standard form, particularly the location of the variables? What's different? Nathan?
X and Y are on the left side.
Yes. The primary difference, variable-wise, is that slope-intercept form, y is by itself, and in standard form, the x and the y are on the same side. Okay? So that's one thing we have to achieve here. The second piece is that standard form doesn't have any fractions. Okay? It is incomplete to write an equation in standard form if you have a fraction. So if we do have any fractions, which oftentimes we do with slope-intercept form, we have to get rid of them somehow, right? So step one, you are going to multiply, multiply each term by the denominator of the slope. Okay? You're going to multiply each term by the denominator of the slope, because what that does is it's going to eliminate the fraction from the equation. And when we start to do examples, you'll see how that happens. Okay? But for right now, multiply each term by the denominator of the slope. And here's the beauty of it. If your slope doesn't have a denominator, such as y equals 4x here, do you have to do step one? No. So this is kind of optional. You only do it if you have to. Okay? Once you eliminate the fraction, then you are going to move the x term over to the other side. And whenever we move a term from one side to the other, what method do we need to use? Caitlin? Very good. Using opposite operations. Okay? Move the x term over to the other side using opposite operations. So step one is eliminate the fraction if you have one. And step two, move the x term over so it's on the same side as the y term, and you're done. Question? No. Okay. So let's take a look at some of these. Everyone got the notes down here? Are we all set? Okay. All right. The first example, y equals 4x plus 7. We're easing into it here. I do not give you a fractional slope, so we do not have to do step 1. Our only thing we need to do to convert this into standard form is move that 4x over. And since it's a positive 4x, what's the opposite of a positive 4x? A negative 4x. Okay? So we're subtracting 4x from both sides. We're not going to divide by 4 here because dividing by 4, how we solve an equation, leaves the x where it's at, right? It only moves the 4. We want to move all 4 x's. So we're taking the group of positive 4 x's and we're taking it away from the right side, so it's gone. And then to keep the equation balanced, we have to take it away from the left side as well. And our equation is negative 4x plus y equals positive 7. Okay, if we take away 4 x's from the right, we have to do it from the left. Since we start with 0 x's, right, it's like we've got 0 x's here. We take away 4 of them. 0 minus 4 is how we get this negative 4. The biggest mistake that kids make in PO22 is they do not change the sign when they move the x term over. They just write 4x plus y equals 7. No, it's not quite that easy, right? Mathematically, what we're doing is we're subtracting 4x from the right, so you have to subtract it from the left, and that's how we get the negative 4x there. Okay? The second one, we do have a fraction, and so our first step says multiply each term by the denominator of the slope, the denominator of that fraction. How does multiplying 3/2 by 2 eliminate the fraction? Right? Why does multiplying by 2 eliminate the fraction? What does that do? Yeah. Yeah, 2 ways to kind of explain it here. Number 1, how we multiply fractions, we go straight across, and we're multiplying by 2, which is like 2 over 1, right? So our numerator is 6. Our denominator, 2 times 1 is 2. What's 6 divided by 2? 3. Right? We're left with the numerator. That's nifty. Or, if you think back to multiplying fractions last year, fifth grade, you were probably taught how to simplify. Whenever you've got the same thing in your numerator and your denominator, you can cancel them out. No? Well, then let's go back to what we've already talked about this year, CO11. Anything divided by itself is 1. We have a 2 in our numerator and a 2 in our denominator. That equals 1. We can cancel them out, just like with all those x's or n's with exponents, right? And we're left with a 3 in our numerator and a 1 in our denominator, equal to 3. Okay? So either way you want to think about it, by multiplying by 2, it eliminates that denominator, and we're left with whatever the numerator is. Okay? Sam, question? No, it's whatever the denominator of the slope is. Okay? What that does, right, our goal is to eliminate the fraction. So we multiply by 2 to cancel that denominator out, and we're left with 3x. Okay? Now, if we multiply one thing in the equation by 2, what do we have to do to everything else? Multiply it by 2. So this y becomes a 2y, and that negative 5 becomes a negative 10. Okay? Because if we multiply one thing by 2 to keep the equation balanced, we have to multiply everything by 2. Katie, do you have a question?
Yeah. So what if it's a negative, like in the next question?
That's okay. You would just multiply by positive 5. Yep. But don't do the next one yet, because the next one is a little bit different. Then we have 2 fractions we have to work with, right? So just hold off on that one for just a minute. Okay. We're not in standard form yet, though, right? Our x and y are still on opposite sides. So we've done step 1. Step 2, now we're going to move this 3x over, and we do so using opposite operations. And again, it's like we have 0 x's on the left side, right? We don't have any there. But when you subtract 3x from that left side, 0 minus 3 is a negative 3x. Don't forget to change that sign when you move it over there. And don't forget that subtraction sign with that 10 belongs to it. It's a negative 10. And so our final equation is negative 3x plus 2y equals negative 10. Okay? Did I lose anybody?
I just don't get. Is that the answer?
Yes.
That equation?
Yes. That is standard form, nothing else. Sam?
I don't get how you figure out what to multiply.
Whatever the denominator of the fraction is.
Oh.
Because that's going to cancel it out. Because, I mean, think about what we know about equations and opposite operations. If we start with 3, right? Start with 3. Then we divide 3 by 2. How do we undo dividing by 2? What's the opposite operation from division? Multiplication. So now if we multiply by 2, we're right back to the 3 again. Okay? So to cancel to get rid of that fraction, whatever the denominator is, that's what you're going to multiply by. Okay? Let's not do the third one quite yet. Let's skip down to the one below it where we only have one fraction, just to practice this a little bit more. Whoa, whoa. Our equation is y equals 4/5 x minus 3. We do have a fraction in front of that slope, so we are going to have to multiply. What are we multiplying by? Nathan?
We're multiplying
by 5, right? That being the denominator of the fraction, we need to multiply by 5 to cancel that denominator out. Okay? The numerator will always be what you have left when you have only one fraction to deal with. That's why I didn't want to do the one up above this quite yet. I want to get this idea down first. But yes, because if you start with 4/5 and you multiply by 5 over 1, that equals 20/5, which is equal to 4, 20 divided by 5. Okay, those 5s just essentially cancel out. Of course, we do need to multiply every other term by 5 as well to keep the equation balanced. So our y becomes a 5y. Our 4/5 x with those 5s canceling out is now just a 4x. And then our negative 3 multiplied by 5 is a negative 15. Okay, we've got to keep this equation balanced as well. Finn.
Hey, with the 4/5 times 5 first,
Yeah.
could you cross out the 5?
You could, right? Since we have a 5 in both our numerator and the denominator, they cancel out, and we're left with 4 over 1, right? Which is just 4. Okay, either way you think about it, it works. What's our next step now? Our second and final step to get this into standard form. Briggs? Opposite operations. We have 0 x's on the left. So when we subtract these 4 x's to cancel them out from the right side, 0 x's minus 4 x's is a negative 4x plus 5y. And that negative 15 is still there on the right side. This would be our answer. Negative 4x plus 5y equals a negative 15. Sam?
Can you do the one above it?
I will do the one above it. How are we feeling at this point? Okay, good. So the one above it now, we've got that double fraction, which means we can't just multiply by 5, right? Because if we multiply by 5, yes, we'll cancel it out in our first fraction, but 3/10 times 5 over 1 gives us 15/10. Oh, darn, that's still a fraction. Okay? We didn't eliminate that. And in standard form, there can be no fractions, right? Every fraction must be converted to an integer. So what do we do instead? Any thoughts? What could we multiply by that would eliminate both denominators and leave us with no fractions. Finn, you need to listen to this. This is kind of important here. What do we multiply by to cancel out both fractions, since we've got two of them? Paisley, your hand was up first, but then you put it down. Do you have same denominator? Look for common ones. That's kind of what we want to do. Exactly. Okay? What you're looking for is the least common multiple of the denominators that you have. So 5 and 10, what's the LCM of 5 and 10? 10. Okay? And what happens when you multiply by 10? This goes back to Nathan's question earlier. Do you always just get the numerator when you multiply? When you've got two fractions, you won't, because the 10 and the 5 don't straight up cancel out because they're not the same, right? What you end up with, 4 times 10 is 40. The negative sign doesn't really matter yet, okay? But thank you. 4 times 10 is 40. 5 times 1 is 5. But what is 40 divided by 5 simplified to be? 8. Okay? And as far as that negative sign is concerned, it was a negative 4/5. We multiplied it by 10 over 1. It's just going to be a negative 8x. We don't really need to include the negative sign in our multiplication because we know it's going to be there in our final answer. Right? And then when we multiply negative 3/10 by 10, what's going to happen here? Negative 30 divided by 10, or negative 3, right? These 10s cancel out, and you're left with negative 3 over 1. Okay? I'm going to stop here just as a quick check. Does everyone see what I just did and how I got to that step? Okay. Why did we multiply by 10? Why 10? That's kind of the key here. Why 10? Paul? Because it's the least common multiple of the two denominators that we have. When you have two denominators, you can't just look at the denominator of the fraction like we did in the other examples. You have to take into account both of them. And so you're looking for the least common multiple of 5 and 10, which is 10. And when you multiply 4/5 by 10, do you see how we get 8?
Yeah.
Okay. When we multiply 3/10 by 10, you see how we get the 3 there? Okay. So then hopefully you're caught up. Yeah. Okay. All right. And then the y term also gets multiplied by 10 because we can't forget about the y. And so we get 10y equals negative 8x minus 3. Okay. Not in standard form yet. What else we do? Kaylin?
Yeah, I move that negative 8x.
And how do I move that negative 8x over? Very good. Right? It's like I've got 0x on the left side right now. Adding 8x to both sides is going to give me a positive 8x. Again, that sign is going to change when you move it, right? Positive 8x plus 10y equals negative 3. And that is standard form. Woo! Good stuff. Paul, what are you looking at? Yes. Yep. Paul's looking at that 7/6 minus 1/4. The LCM for that one is going to be 12. Okay. Now, when we say that, we multiplied by everything by 10 and it doesn't change, it keeps the equation balanced. That's the phrase that I use it for. How does it keep the equation balanced? What does that mean? Like, how is our original equation, y equals negative 4/5 x minus 3/10, balanced with 8x plus 10y equals negative 3? They look very different. But when I say it keeps the equation balanced, what does that mean? Katie?
You have to keep like the equation equal to what it was before.
Yep. Keep the equation equal to what it was before. These two look very different, though. They don't look equal at all. So when we say we're keeping the equations equal, what do we mean? What are we keeping equal? The answer lies in the variables. Whatever values for x and y work in the originally equation, say you plug in, I don't know, 20 for x, whatever value you get for the y will be the same thing, the same values for the variables that work in the standard form equation. To where whatever, if you plug in 20 for x, whatever y equals from above, you plug that in, you're going to get -3 as a value. Okay, so what we're keeping equal are the values of the variables that make this equation true, right? If we were to graph this, any ordered pair that would be a solution for x and y would also be a solution down here. Okay, so the numbers change, but it's the value of the variables that we're keeping equal, that we're keeping the same. We're gonna stop here as far as the teaching is concerned. Your homework since tomorrow's a retake day, for Monday is to finish this first page and first page only. Okay, so we've done 3 of them, 4 of them. You've got 5 of them to do on your own. Work must be shown. Okay, I need to see what you're multiplying by. I need to see you moving the x term over. Work is a requirement, but you've only got 5 to do for Monday. By golly gee, folks, if we don't play the number game Monday, we need to do a gut check. Okay, see where our priorities really are. Yes? The end of the try is December the 1st, I believe. I think we're off of school the 2nd, though. So I think the last day for try stuff is the 1st. Yeah. The 2nd is a grading day. So I have to be here grading all your stuff. But yes, Paisley. So the common multiple for the last one, I'm not going to give you the answer, and I don't want anyone to say it, but you're looking for the least common multiple of 8 and 5, meaning what's the first number that both 8 and 5 can go into. Okay? The first number that both 8 and 5 can go into. Like we knew the LCM here was 10, because 10's the first number that both 5 and 10 can go into. 5 and 10 are both factors, right? So, okay, that's all I'm going to say. Any questions, comments, concerns, complaints, compliments, congratulations, and criticisms? Okay, since you don't have to have this done for tomorrow, we can all cheer the Packers on to victory over the Titans tonight. That's how you math.
Don't forget to like and subscribe.
And my touch is off.